part where the lander is responsible for, for the digging and for the collecting and the sampling, it will do so with robotic arms. Is that process fully automated? Is there any interference from, let's say, humans on Earth for that process?
There are two instruments that we brought to the lander. One is the visible and near infrared camera that can help, as Professor Yang mentioned, the scooping of samples on the lunar surface. Another one is a radar, a penetrating radar that can penetrate the ground, that can tell the character of the ground and the hardness and the softness of the ground, so that the drill can drill 2 meters into the ground and bring samples back. So there are two different methods of collecting samples at the same time. We do bring these two instruments on board. We might analyze on the ground by these parameters and informations prior, during, and after the drill.
All right, it looks like we're just moments away from the launch of that rocket. This is a Long March 5 rocket. We're now 3 minutes away from the launch here. When we talk about what's going to happen on the moon later in this mission, people say that the docking and the rendezvous, as Professor Yang mentioned, is extremely difficult. Help us understand how that process will happen and what should we look out for.
Well, for a lunar orbit rendezvous and the docking, first you should have a very accurate measurement. So you see we have all kinds of instruments such as docking and rendezvous radar, which is, you can recognize that as a derivative from the docking and rendezvous radar of the Shenzhou spaceship, but it is a much smaller version. Also, it has a new function to have vehicle-to-vehicle communication, which can exchange data. So you see, this instrument is very critical for our lunar orbit rendezvous and the docking. One side from the ascender and one side from the orbiter. With this instrument, we can help the two spacecraft to measure the distance from each other and also measure the angles. And then from the final step, the two spacecraft should docking autonomously with the docking mechanism, which is quite different from the mechanism we used by the Shenzhou spaceship and our space station. Or from the front, we can hear that it's 2 minutes counting down, T-minus 2 minutes counting down. And I believe that the spacecraft has changed the power supply from the launch pad to the vehicle itself. And the onboard computer will also have the control of all the critical functions.
Professor Yang, that's the platform, that's the pad opening up to release the rocket, is it?
Yes, we can see that all the rotational platforms has already been opened, and only a few connections are still remain. So we can see it's going to launch,
indicating that the final preparation, the very final touches, are now being done to the rocket.
You can see there's still a wire connected to the vehicle. That is a wire to have the measures.
1 minute countdown till launch. If you're just joining us here on CGTN, you're looking at live pictures coming out of Wenchang in Hainan province, where the Long March 5 rocket is getting ready to lift off. This is the Chang'e 5 mission that will endeavor to bring back soil and rock samples from the moon. 30 seconds till launch. 20 seconds now. As you can see, the countdown on the screen: 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Lift off.
时间动4时3度分2幺秒，发动6毫秒。程序转弯。阵地1212跟踪正常。
Personnel on the ground reporting that the remote sensing data indicate that the flight is going smoothly. Why do we need those data?
This is to keep the tracking of the predetermined orbits and the speed and the altitude, so to keep track on the normality of this rocket.
And we should also notice that the rocket is not flying straight up; it's going sideways. There's a little turn.
It's called pitch over.
Pitch over.
Yes. So the first critical step will be after the tower is cleared, will be the pitch over to the so we call the launch direction. With this direction, we can determine the orbital plane. And from you see, this is a video from the camera mounted on the rocket itself on the core stage. We can see 2 of the 4 boosters. Well, the 4 boosters provided 90% of the thrust during the liftoff. So on this stage, mainly the thrust is from the 4 boosters. And after pitch over, the next critical step will be the separation of these 4 boosters.
Yes.
Yes, exactly.
And we keep hearing that the monitoring and command center reporting how the flight is going to continue. They're going to continue to track the flight of this rocket, and then a few minutes into its flight, we'll see the boosters come off the rocket, and you're looking at the pictures being captured by a camera just attached to the body of that rocket, showing, as Professor Yang mentioned, 2 of the boosters there. There are a total of 4 boosters on the body of the rocket. They will all come off later in the flight and allow the separation of the first and second stage rockets.
So each of the booster has 2 engines, so total of 8 engines on the booster, and also engines on the core stage. So the boosters are composed by liquid kerosene, liquid oxygen rocket engine, but the core is cryogenic, which is liquid oxygen and liquid hydrogen.
Help us understand the choice of fuel here.
Well, the liquid kerosene, liquid oxygen works very well in the atmosphere, where the liquid oxygen and liquid hydrogen works better in outer space, which has better propellant propulsion rates.
Okay, the boosters
and
have
the
been
boosters
separated very
are
properly.
being separated. They come off to, because they burn out the fuel. They have to come up to allow the rocket to continue flying.
So now we see the core engine is burning, which is the liquid oxygen and liquid hydrogen.
So at this stage of the flight, what the rocket is doing is that it's accelerating in terms of speed, and until it reaches that height, it will continue to increase velocity.
Yes, it was increasing the velocity and altitude at the same time.
From this 3D animation, we can see the data link from the vehicle to different ground stations. We have ground stations at the launch center, and also have the stations in the Xisha Islands, and also at every critical point, for instance, before the spacecraft separation from the rocket, we also have the ground have space tracking ships in the Pacific Ocean.
The number we see on the screen is the number of seconds into the flight. So we're now more than 4 minutes into the flight.
At the current stage, the core stage work with the what's so-called the YF-77 rocket engines. We use 2 engines in this core stage of the Long March 5. Each have a thrust about 50 tons. So this rocket engine is the largest, as Mr. Xu has mentioned, the liquid hydrogen and the liquid oxygen engine, which has the highest specific impulse in China's rocket engine families.
And the next noticeable development would be the separation of the first stage and second stage rockets. How long till we have that? A couple of minutes?
This is a camera video from the inside the payload fairing.
The camera seems to be working very well.
The payload fairing is jettisoned.
Okay, the fairings. The fairings are at the very top of the rocket. They protect the spacecraft, basically.
Yes, once it's out of outer space, once it's out of the atmosphere. It doesn't create any frictions. So we have to lose weight, as well as the boosters.
Absolutely.
We drop all of them to increase the the propulsion ratio so that we can have better propulsion for speed and for
Absolutely.
altitude.
So are we now out of the Earth's atmosphere?
Yes, we are out of. I think it's more than 100 kilometers above Earth.
The atmosphere is about 70 kilometers.
Yes, about 70 to 110. Yes.
Okay.
From the voice, we can hear that the telemetry data received from the Xisha Islands, the ground station located on the Xisha Islands, received the data, and it shows that the data is works properly.
2521遥测信号正常。
So normally there are two different kinds of observations. One is telemetry tracking, another is optical observations. So once it's above the optical observation capabilities, we'll rely on the TTNC, telemetry tracking control command.
As Mr. Xu mentioned, we have optical telescopes to observe the flying, and also we have ground-based readers to measure the trajectory of the rocket.
And that's what we've been hearing.
西沙3113跟踪正常。
Yeah, just now, as we've been hearing, those are personnel on the ground, some in Xisha Islands, tracking the flight of the rocket.
The voice mentioned the 313 is the trajectory tracking radar we use in every mission from the Wenchang Satellite Launch Center.
Understood. So now this will be actually a longer phase in that flight. You know, we've had the boosters come off, we've had the fairings come off, we've had.
But this is still the critical moment because the core engine has experienced a couple of times of failure in the past 4 missions. So we have to make sure that we witness the separation of the first stage with the second stage, and the core engine burns properly so that we can ensure the success.
The first stage use, as Mr. Xu mentioned, the cryogenic propulsion system with liquid oxygen as the fuel and the liquid hydrogen as the fuel and liquid oxygen as the oxidizer. It has a very high specific impulse, so this with little consumption of fuels, it can provide much more.
Now the first stage
energy.
and the second stage.
Great.
Rockets are being separated. We're hearing applause from the control and command center. Everything seems to be working just fine.
So the second stage, we use the YF-75D rocket engines, which also use the liquid hydrogen and the liquid oxygen as a propellant. The thrust is smaller, but the specific impulse is even higher than the first stage.
And later in the flight, that engine on the second stage rocket will be shut for a while when the rocket is cruising.
Yeah.
And there will be a second ignition later in the flight.
Exactly.
Is that correct?
So you can see from the 3D animation, we have data links from the ocean surface to the I believe that is a space tracking ship. And to the vehicle, and also as you mentioned, after this spacecraft, the rocket enters what we call so-called the parking orbit. The rocket engine will be shut down, and we will have a coasting phase with no propulsions, and we will have the second ignition near the equator to have the lunar orbit from the low Earth orbit to the lunar transfer orbit. Now we can see the videos mounted from the camera mounted on the rocket, and also this is the camera mounted near the rocket engine. We can monitor the working of the YF-75D.
You can see the flame coming down from the underpart, which is the burning of the engine.
And it says second stage engine right there on the upper right corner of your screen, indicating what this camera is showing us. And these cameras do seem to work extremely well in outer space.
And you see that because videos always have a very large amount of data, so the transfer rate from the spacecraft, from the rocket to the ground station, has a very high data transfer rate. So this is a very high requirement.
And how long is this process, until the engine shuts off for that brief period until it hits a second ignition?
It normally takes a few minutes.
A few minutes.
Yes. So it very much depends on the orbit that you are planning. So this is a translunar orbit. So it depends on different missions. So the timings are different.
So we're basically waiting for when the rocket and the spacecraft eventually hits that translunar orbit.
Yeah. We will have number of maneuvers before it takes off to the lunar orbit, translunar orbit. And then during that course, we will have a number of corrections. It depends on the precision of the insertion of the spacecraft to that orbit.
What type of maneuvers?
It's like Professor Yang mentioned that once we're leaving the Earth orbit, we'll accelerate to the lunar orbit. And once we reach the lunar vicinities, we have to slow down, what we call a brake, to insert into lunar orbit. So that, and also we will descend gradually from a higher altitude, like 300 or 400 kilometers, to eventually less than 100 kilometers, so that we can prepare for the descent of the ascender and the sample return mission.
Well, you see from the camera mounted on the rocket, we can see that the rocket itself is already under the sunshine. Although we in Beijing here is still at night. Great. The first shutdown of the rocket engine on the second stage. So now we are in the coasting phase.
Coasting phase.
Yeah. So it's already in low Earth orbit with altitude of about near 200 kilometers. We will fly to, as I mentioned, fly to a place near the equator and then ignite again.